And now we're going to use the properties of the normal distribution to be able to draw any type of normal distribution that we already know the parameters. So that's the point of a distribution statement. As you can see here, what we have is a distribution statement for normal distribution, which says X, which means the random variable looks like a normal distribution. And then we have the 8 here, which is the mean, and the 2 here, which is the standard deviation. So knowing these two parameters and that this is a normal distribution, I can just draw this now and I'll know what this picture looks like. So the first thing we draw is that line on the bottom that just illustrates the number line. So we know that there's a range that the normal distribution follows. And then we know that every normal distribution has this line in the middle where there is a mean, median, and mode that goes to this line. And so here we know that this number is 8. It tells us right here that this center part here is an 8. So I'm going to put that there. And we know now that the bell curve is centered around 8. So let's use one of the properties of the bell curve. So we've used this unimodality property, right? That's what this is. Now we're going to use the shape property. And we know that every bell curve has this same shape. And I am drawing this freehand, and that can tell you why on the assignment I'm giving you a template to be able to use, but I want to show you can draw it freehand. So they all have this same bell shape here. Now we know that this bell shape is symmetrical, so we're just going to imagine that these two parts are perfectly exactly symmetrical. That's another property of the bell curve. And then we also know by that 68, 95, 99.7 rule that when we go out from this mean, median, mode, we go out by 1 standard deviation. We know that about 66% of the data is between plus or minus 1 standard deviation. And then we know that about 95% of the data is plus or minus 2 standard deviations. And we know that 3 is plus or minus 3 standard deviations is between that is the 99.7. So we're going to draw those now. I'm going to do that with blue. We know where those lines are. Now, that empirical rule tells us that the lines are always in the same place. So it doesn't matter what the standard deviation is. These lines are always right about here. They're always at about where the curve kind of inflects there, and then where it inflects again. And then the last line is all the way out. And so using this number 2 here, which we know is the standard deviation, we know that 8 minus the standard deviation is 6. So there's 1 standard deviation in between here. And 8 plus the standard deviation here is 10. So we can identify where those lines are. And we can keep going with the other lines too, right? So we add a standard deviation here to get 12. And we add 1 more to get 14. And so we've identified on this particular variable what points in a normal distribution match with the numbers that are in this variable. So then 6 minus another standard deviation, that's 4. And then 4 minus standard deviation is 2. So now we've drawn out this variable. We know exactly how much proportion under the line matches with every point on the range. So if you were to tell me something like, I want to know how much of this curve, what's the probability of getting an 8? Well, I know that 8 is the mean, median, mode here. So that means that there's 50% probability to the left of this curve. There's also 50% probability above, right? So this is exactly the halfway point. 8 is also called the 50th percentile. And you would say, well, what about 10 or 12? Let's use 12 here, because that's one of the confusing parts. Between 4 and 12, we know that there is 95% of the data. So plus or minus 2 standard deviations is 95% of all the data under the curve. Now, some people will get confused and say, well, that means 12 must be the 95th percentile. But that's not the case, because remember, if it's between these 2 points is 95%, you're forgetting about this little bit here at the end. So the 95th percentile is actually going to be somewhere close to 12, but that would be, and I'll mark that with a different color, the 95th percentile might be right about here, because that would be 95% of all the data to the left of the curve is going to be that 95th percentile. So as you can see, normal distributions are very useful. Once you get the hang of it, they're actually quite they're easy to draw because all the properties are always the same. And so you just want to pay attention to whatever the parameters are in your particular variable that you're looking at to be able to find out where the points are on that particular curve.